Hello everyone, my name is Fangzhou Wang, and I'm from the Chinese University of Hong Kong. Today, I'm glad to present our work, FastPath, Fast Pin Access Analysis with Incremental Set Solving. Pin access is one of the most complicated subproblems in VLSI routing for the following reasons. First, the pin shapes are not necessarily rectangles. It can also be complex rectilinear shapes. Second, the problem scale can be large. Over millions of pins might need to be analyzed at the same time in some of the designs. Based on that, it is required that the pin-access solution of one pin does not have violation with fixed objects like other pins or cell blockages. Also, the pin-access solutions of different pins should not conflict with each other. Here is a pin-access problem instance and one of its possible solutions. Say we have 7 pins in total. Some of them will be accessed by M1 metal plus a via to a grid point on M2, while some of them are accessed by a single via. In this work, we have the following definition for the P-access problem. Given a placed design where we know the track pattern, standard cell information, and net list, we want to find a routing scheme such that each net pin is connected to a nearby grid point using routes, such that no routes will cause design rule violations with fixed metals or each other. Here is the overall flow of the proposed framework, which contains 3 stages: pattern-based analysis, inter-instance analysis, and incremental set solving, which is for route selection. First, we will generate candidate routes for each pin. For each access grid point, we will generate 2 kinds of routes using each via type. And then we will do instance pattern-based analysis and inter-instance analysis to filter candidate routes with design rule violations. A sweep line algorithm is proposed for DRC checking. Our algorithm utilizes the fact that the cell instances have a limited height, and the routed rectangle will cause violations with only a few fixed rectangles within a small distance in the horizontal direction. That's what we show here in the yellow region. After that, we can build a conflict graph, which marks the violation between different candidate routes. The graph can look like this for the toy example, where each node represents a route, and intra-instance conflict and inter-instance conflict are marked in those colored edges. With the conflict graph, we will do incremental set solving for route selection, and further, we can form a pin access scheme. Each route for a pin is assigned a cost according to how likely it will bring more difficulty to detail routing. To prioritize the preferred routes, only the route with the lowest cost for each pin is enabled at the very beginning. If no solution can be found, the preferred candidate routes will be extended progressively until a solution can be found. Experimental results show that ours are capable of producing DRC clean pin access schemes with no failed pins. And compared with the state-of-the-art work, ours is on average 14.7 times faster. We also show that with the incremental set solving flow, we can get pin access solutions that are optimized towards certain metric. And in our case, it's out of guide grid point and HCWL. Finally, to verify the effectiveness of our approach on advanced technology nodes, we synthesized an open source processor IP core with about 80,000 instances and over 500 instance patterns with the ASAP 7nm library. With simple modification, like we handled more design rules, it took ours only 4 seconds to generate DRC clean PXS result. Here is the result for one of the AOI 221 cell from the design. And that's the end of my presentation. Thanks.